All right, so let's talk the difference between uniqueness and existence. So a solution exists if it's consistent, and that will be happening if when I'm looking at the augmented system, so that means with the equal signs, that I do not have a pivot column in the last column. If I did, I would have 0 equaling B. So remember, an augmented matrix comes from the whole system with the equations. Coefficient matrix is just the numbers in front of the x's. All right, so make sure you know that this applies for the augmented matrix alone. So what are the two cases for consistent? Two cases for consistent are unique solution and infinitely many solutions. All right, so let's go solve this one. Let's put it into an equation. So I already see I only have 3 equations and 4 unknowns. So I know that a unique solution is not a possibility. All right, so let's do it. So 2 times row 1 and add it to row 2. Oops, lost a negative sign. So multiply by 2 and add is 0. Multiply by 2 and add is 0. Multiply by 2, I get 3. Multiply by 2, I get 1. And 3. Okay, so let's get rid of this also. So let's multiply by -3 to row 1 and add it to row 3. Remember, you're always adding the rows. So that gives me a 0 there. Multiply by -3, so that gives me a 6 and a -6. That's a 0. -3, 3, and so it gives me a -3. So that gives me a -9, -1. Multiply by -3, 0, and 2. All right. So I am not going to multiply this by 1/3. I'm just going to leave it like this and then just add row 2 and row 3 together. So 1, -1, 3, 0. Keep this the same for a second. And then just add these rows together. So 0, 0, oh, and look at what I get here. I get a 5. Okay, so this is an augmented matrix, yes? Because I got it from the equation. This here, I have a pivot in the rightmost column, so this last row means 0 equals 5. So therefore, I know that this system is inconsistent. So this is just confirming your work. This is what I got. So this is a pivot, and this is a pivot, and this is a pivot. This is just in echelon form. But because I have a pivot in the rightmost column, that means it's inconsistent. All right, let's play with some more with H's and K's. So again, we have to do a little bit of row operations here. So I multiply 2 times row 1 and add it to row 2. So I get a 0, multiply by 2 and add. So that would give me a 1, and this would give me an H plus an 8. Okay, so they're telling me this is an augmented matrix, so there's equal signs here. So what values of H makes this consistent? So this last row says 1 times x2 is equal to H plus 8. So since I already have the number 1 in front of x2, there are no restrictions on H. I could have x2 equaling 0, so H can be the element of any real number. All right, this one's going to be a little trickier. So let's do a little bit of row operations here. So I want to get a 0 here. So -4 times row 1 and add it to row 2. 1, H, and 2, so I'll get a 0. So if I multiply this by -4 and add, I'll get 8 minus 4H, and -4, I'll get K minus 8. Okay, so for there to be no solution, I would have to have 0x2 equaling a number, right, from that last row. So that means 8 minus 4H times x2 equaling k minus 8. To be no solution, I want 8 minus 4h to equal 0 and k minus 8 to not be 0. That's when I would get no solution. So that means h is equal to negative, or just 2, positive 2, and k would not be 8. Okay, so again, let's think about what unique solution means. So unique solution means that this, let me just write it again, 8 minus 4h times x2 is equaling k minus 8. This 8 minus 4h would not be 0, and k minus 8 could be any real number. So k can be an element of the reals, and what I need here is for h to not equal 2. All right, for infinitely many solutions, I need 0 equaling 0 in that bottom row. So that must mean that I have to have 8 minus 4h to equal 0, and k minus 8 to equal 0, so k's got to equal 8, and h has got to equal 2.